Now we're going to practice solving logarithmic equations. There are two different situations in these equations. One where we have the same log on both sides, and one where we only have a log on one side. First, we're going to focus on if we have logs on both sides. If that is the case, the first thing we need to do is simplify anything into the most condensed form. It might start off pretty expanded. We want to condense it down. Then we are just going to focus on the answer, what is inside of those logs, and set them equal to each other, and we'll solve. And then when we're done with that, we need to check our answer because we don't want to have any negative arguments. So in number 1, we have log base 5 of 4x minus 7 equal to log base 5 of x plus 5. I don't have anything that I need to condense on either side, so now I can just focus on what is inside of those logs and set them equal to each other. So 4x minus 7 equals x plus 5, and we solve. Subtracting x from both sides, I get 3x on the left. Adding 7 to both sides, I get 12 on the right. Dividing by 3, x is equal to 4. Now I'm just going to check my work. On the left, we have log base 5. 4 times 4 is 16. 16 minus 7 is 9. We don't want to have any negatives inside of that log. On the right, we have log base 5 of 4 plus 5, which is also 9. That's not negative, so we are good. Now we have log of 2 equal to x log of 8. This one we need to move the x to the exponent first, and then we have a log equal to a log. So I'm going to start by saying log of 2 equals log of 8 to the x. Now I have just a log of something equal to a log of something. There's nothing else I need to condense. So we can just focus on the insides. 2 equals 8 to the x. Now since we're solving for an exponent, we're going to have to change that base. I can change the 8 to a 2 cubed. So I have 2 equals 2 cubed, and then keep the x. This 2 on the left-hand side has a power of 1, and we can set those equal to each other, those exponents. So 1 equals 3x, dividing by 3, our x value is 1/3. Now I just want to make sure I don't get any negatives. There's no x on the left-hand side, so I don't need to plug anything in. On the right-hand side, when I plug in 1/3, nothing becomes negative, so we are good. Now I have log base 6 of n minus log base 6 of n minus 1 equal to log base 6 of 3. Since I'm subtracting two logs on the left-hand side, I need to use that quotient rule. Whatever's being subtracted goes to the denominator. Whatever is not being subtracted stays in the numerator. So I have log base 6 of n over n minus 1 equal to log base 6 of 3. There was nothing to condense there. Now I can just focus on the insides. N over n minus 1 equals 3. Since I have n in both the numerator and the denominator, I'm going to start by multiplying by n minus 1. So n equals 3 times n minus 1. Distributing the 3, n equals 3n minus 3. Subtracting the 3n, negative 2n equals negative 3. Dividing by negative 2, n is a positive 3 over 2. Let's check that work. If I substitute that into the first log, I have a positive. If I substitute that into the second log, 3 over 2 minus 1 is positive 1/2, so it stays positive, so we're good.